Example 2, 3, 4, and 5 are all the exact same kind of problem. I don't know if I'll get a chance to get all 4 of them done. If I don't, I'll make videos outside of class, watch them over the weekend and just see. They all work the same way. All right, so keep that in mind. Theta is an acute angle and sine of theta is equal to 5/8. So let's start here. Anytime you're told something along those lines, a trig function of some unknown angle equals a fraction, or equals any number for that matter. That allows you enough information to draw a triangle. I don't really know what it looks like. Let's just go with that. All right. So start with the right triangle and pick one of the angles to be theta. It doesn't matter which one you pick. I'm going to pick this one down here. Okay. Which trig function did they give me?
Sine.
Sine. Okay, so let's start with sine. Sine is what? What over what?
Opposite over hypotenuse.
Opposite over hypotenuse, right? And they told me the sine equals 5/8, right? So what that tells me, if I draw a right triangle with an opposite side measuring 5 and a hypotenuse measuring 8, that should represent this correct angle, right? So for this, the opposite side's over here and the hypotenuse is over here, right? I can also write them this way, like so. Yes?
So you get the same answer no matter which.
Yeah, if I put theta up here, phi would have been down there then. So again, it's in relation to the angle you're working with. I usually draw it down there every time. So if I always draw my triangle in this manner and it's always this angle down here, this is always opposite, this is always hypotenuse, that's always adjacent. So if I create a structure for myself that I always do the same thing every time, it makes it easier for me.
Okay.
But if I put it up here, phi's down there now, still the opposite side, the adjacent's going to be over here, it'll be whatever it is. So it doesn't matter where you put it. Just don't put theta down here in the right angle spot. That wouldn't be good. All right, but pick either acute angle you can do. So, is everybody okay with how I went from this information to that triangle? So again, anytime you have trig function of angle equals fraction, you have the ability to draw a right triangle, giving us a picture view of what that means. All right. The adjacent side down here is unknown, but we can of course use a Pythagorean theorem to determine that. We know that we'll call this a for adjacent. 25 plus a squared is equal to 64. Move the 25 over, that means that a squared is equal to 39. We take the square root, we get a is equal to the square root of 39. And just like that, I now know all 3 sides. Now the last thing they do is they then ask you to find something. They say the sine of this angle is equal to this number, find me the secant. Alright, now, we have our cool little SOHCAHTOA thing going on for sine, cosine, tangent, right? Let's look at SOHCAHTOA. SOHCAHTOA. Which one is secant related to?
Cosine.
Cosine. Alright, so cosine gets me down to secant, right? Cosine's adjacent over hypotenuse, so secant is hypotenuse over adjacent. So if I want to do secant of theta, hypotenuse 8 over adjacent square root of 39.
Hypotenuse over what?
Adjacent. So again, if I see that cosine is adjacent over hypotenuse from SOHCAHTOA, and I know that cosine goes to secant, reciprocal, so instead of adjacent over hypotenuse, I reciprocate, so it's hypotenuse over adjacent. All right, and again, I'm going to get an answer. If that answer is in good form, great. If it's not, fix the form. Multiply top and bottom by the square root of 39 is going to give me 8 times the square root of 39 on top, over 39 on the bottom. And that will be the answer. Okay, so each of the examples, 2 through 5, are the same kind of problem. Trig function of angle equals this, find the other trig function. All right, so they're all going to be this way. Again, I'll get through as many as I can before the bell rings, but we'll see how it goes.